Python is a crucial programming language among data analytics, data science, and data professionals. Companies all over the world use Python to harvest insight from their data sets and gain a competitive advantage against their competitor. So welcome back to the channel and welcome back to Excel Island, where the goal and objective is to learn and master Python over the next 100 days. Today is day 16. We're focusing on our first project and our first case study, which is the ACA statistics in Python. Welcome to this case study or to this project. So it is going to be a guided project. We are going to be guided on what to do and what not to do and use core skills in. So we're going to be using random number generators, loops, and matplotlib to calculate your chances of winning a bet in the ACA statistics project. So I look forward to seeing your project at the end of this video also. So all the data set exercise files or CSV files and Python notebook that I'll be using is already linked under the YouTube description. So do make sure to download those files and practice along with me. Without further ado, welcome to this case study and let's get started on the ACA statistics project and calculate your chances of winning a bet in Python. Let's go. So basically, we will be live streaming. This project will probably be broken down into three or four live streams, depending on how the content of the case study, how huge it is. So I go under the career tags section real quick so you can see what I'm talking about. Mm, I'm kind of taking a peep at my internet to see how strong it is, so I'm getting a good or a good result, a good feedback on YouTube. So if I go to the career tag section, we actually subscribe to a 1 year subscription on the platform. So if I click on data analyst in Python, so when we started this fun way of learning, it all started with associate data analyst in SQL. We completed that for a period of 100 days. Then we moved to data analyst in Power BI, and that went for a period of 70 days, 69, 70 days. And now our last tool to learn for this year, 2023, is the Python uh, programming language. And that is what we are basically doing now. So we started a couple of live streaming ago. So if you are just new to the channel, my name is Abatan Sheriffdeen. I'm a top-rated plus freelance data analyst on the Upper platform, and I'm looking to upskill myself to become relevant and have a competitive advantage as a freelancer and a remote worker. That's why that is the goal behind me upskilling myself in all these tools. If I click on data analysis in Python real quick, so if you want to catch up on the previous live stream, I encourage you to go to the live stream tab on the channel so you can see all what you've learned so far from day 1 all the way to day 16 today. So you can understand this project a little bit. So we've covered loops, dictionaries, pandas, matplotlib, and a whole bunch of other concepts in Python before we go to this case study actually. So you can see we've covered quite a lot. Let me show you really quick. We've covered introduction to Python, which is just the basics of Python, the Python list, function and packages, and NumPy. Then after that, we moved to intermediate Python, in which we covered our matplotlib, dictionaries and pandas, logic, control flow, and filtering, loops, and finally we are on the case study, ACA statistics case study, which is a guided project. So that's all we've done so far. So we'll be using the knowledge of dictionaries, pandas, loops, and random number generators to solve this case study, to solve this challenge. So without further ado, I'll just click on. So I can click on this. So welcome to the case study. Oh, my feedback is kind of blurry. That is my network acting up. Sorry about that. So let's continue from this case study and see what we have to learn in this case study. So while that is coming up, so this is the slide for the case study. I'll just take that to the other side of the screen here. Okay, so this is what we covered on the last live stream. Just a little bit of knowledge there. So this is what we are focusing on lab rules. We're using our for loops in Python on dictionaries, and we also use for loops in Python on NumPy arrays. So this is what we covered on the last live stream, which is day 15. So you want to catch up on this on day 15, so you have a good understanding of what we did there. So that's by the way though. So generally, if you want to catch up on what we've done so far, I encourage you to go to the live stream tab on the channel and start from day one, so you can have a better understanding of what is happening here. So welcome to the case study one more time. Let's get into it.
Well done, and you're on the home stretch now. This chapter will be a bit different from the others. Step by step, we're going to work towards a cool script using everything we've learnt during this course. Imagine the following. You're walking up the Empire State Building to DataCamp headquarters and you're playing a game with a friend. You throw a dice 100 times. If it's 1 or 2, you'll go one step down. If it's 3, 4 or 5, you'll go one step up. If you throw a 6, you'll throw the dice again and will walk up the resulting number of steps. Of course, you cannot go lower than step number 0. And also, you admit that you're a bit clumsy and have a chance of 0.1% of falling down the stairs when you make a move. Falling down means that you have to start again from step 0. With all this in mind, you bet with your friend that you'll reach 60 steps high. What is the chance that you'll... It's a complex assignment. One way to solve it would be to calculate the chance analytically using equations. Another possible approach is to simulate this process thousands of times and see in what fraction of the simulations that you reach 60 steps. This is a form of hacker statistics. As you can probably guess, we're going to opt for the second approach. The first thing we'll need are random generators, so we can simulate the dice. You need to import NumPy, and inside NumPy, there is the random package. Inside that package, we find the rand function. Let's try it out. We get a random number between 0 and 1. How was this random number created? Well, computers typically generate so-called pseudo-random numbers. Those are random numbers that are generated using a mathematical formula starting from a random seed. This seed was chosen by Python when we called the rand function, but you can also set this manually. Suppose we set it to 1, 2, 3, just the number I chose, like this, and then called the rand function twice. We get 2 random numbers. Now, if I set the seed back to 1, 2, 3 and call rand twice more, we get the exact same random numbers. This is funky. You're generating random numbers, but from the same seed, you're generating the same random numbers. That's why it's called pseudo-random. It's random, but consistent between runs. Now, this is very useful because it ensures reproducibility. Other people can reproduce your analysis. Let's use this randomness in a new example now. Suppose we want to simulate a coin toss. First, set the seed. Again, this could be anything, and then use the randint function. To have it randomly generate either 0 or 1, we pass 2 arguments. The first argument should be 0, the second one 2, because 2 is not going to be included. If we print out coin and then run the script, we get a random integer, 0. You can now use this coin to play a game. We extend the code with an if-else statement. If coin equals 0, we print out heads. If it equals 1, we print out tails. If we now run this script again, coin again equals 0 because the seed is the same. This also means that the condition is true, so the string heads is printed out. This was a first example on how you can use random numbers to simulate real-life situations that involve chance or probability. Now head over to the exercises and start to code your Empire State Building simulation.
Oh, the random number idea is kind of tricky. We're going to give it a shot while reading the instruction and try to solve it. But before that, let me just launch my Jupyter notebook real quick from here. I believe you should know how to install the Anaconda Navigator. If you don't, just go to day one live stream where I showed you how to install this package that gives you access to other Python environments for your analysis. I'll just open my Jupyter notebook there real quick. Voila. So I want to open my own Jupyter notebook file that I can simply use for this. Let me just go to my downloads. I'm not going to my OneDrive folder yet. Let me go to my downloads, DataCamp resources, then Python for data analysis. I could just go to the data sets and create a new Jupyter notebook here. So I'll just create a new one. So just create a brand new notebook. Hey, Sandeep. Nice to have you here. Okay, let's select this. Let's rename this to case study. Case study. Aka statistics. This is statistics. Okay. We have it there. So, but funny enough, let me just go to another file and import our packages. Normally, I'll just copy this. But we are going to be making use of only NumPy in this case study. I just love importing everything. Creating the first cell should be for imports. I just run the code. So we are setting things up. I can just close this. Okay. So we are prepared for this case study. All right, so let's continue reading the instruction. So random floats. So randomness has many uses in science. That's statistics, cryptography, gaming, gambling, and other fields. We are going to use randomness to simulate a game. So let's create a game in Python. Interesting. All the functionality you need is contained in the random package, a sub-package of NumPy. Oh, interesting. So we have NumPy imported already. So the random package is a sub-package of NumPy that we're going to make use of. In this exercise, you will be using two functions from this package. So you want to use two functions from the random sub-package in the NumPy package. So the two functions are seed and rand. So seed set the random seed so that your results are reproducible between simulations. As an argument, it takes an integer of your choosing. If you call the function, no output will be generated. While rand, on the other hand, if you don't specify any argument, it generates a random float between 0 and 1. Okay, between 0.0 decimals, the highest is 1. So it says import numpy as np. We've done that. Okay, how do we do that? The Python shell here is kind of white. Let me change it to, let's see, dark mode. How do I change it to dark mode? This is white. Let me see if I can type something. I can't even see what I'm typing there. That's funny though. Mm, let me see if I can get this back to dark mode. Mm, hold on a minute. Few seconds there. It has always been dark mode. I have no idea how that changed to a white mode. Let me see if I can just change the settings. I have no idea how that is just turned into a white background. I'll just head back there now and see how to. Oh, so let's get back to it though and see. So I've read the instruction earlier. The background is just white and I can't seem to type anything there. So waiting for the interface to complete. Oh, this is what we wanted to do the other time. And need it to be black like this. Interesting. So it is back. So the first instruction says import numpy as np. So I just import numpy as np. It now says set a seed. So set a seed. So our seed. So we're going to use the random function. Uh, this rand, this seed function rather, which is the subpackage of the rand subpackage. So what to set a seed? I'll just say np dot. I mentioned the random package first. Random dot the seed function. Seed. So in between the seed, it say use seed to set a seed as an argument and pass 1, 2, 3. Then we pass 1, 2, 3, 1, 2, 3 into the seed. Generate and print random float. Generate your first random float with rand. Then I'll just say np.rand, np.random.rand. When we run the code, let's see what we have here. Ooh, we run into an error. In our run, ensures reproducibility. Okay, it's normal. Import numpy. Oh, my import here is a capital letter when it's supposed to be a small letter. That was my mistake there. Let's run it again. Aha, you see? So it worked fine. So let's try it out in Jupyter Notebook here. So if you run this np_random.seed, it's not going to return anything. We now use a rand function. We just generate a random number between 0 and 1. So that's what this function does. The rand function. Simple like that. Let's submit and see. So I'm supposed to use the print here in this case. So in the interface, you need to use the word print. So you can see it prints 0.66. And if I run the code again, it's going to generate another random number. Let's see. You can see it just keeps generating random number. So that's what this function does. It's as simple as that. Pretty straightforward. Let's submit. Great results. So we've learned to generate random numbers in Python. Now let's roll the dice. So in the previous exercise, you use rand that generate a random float between 0 and 1. As Igor explained in the video, you can just as well use rand ints, also a function of the random package, to generate integers randomly. So instead of generating decimal numbers, we want to generate integers in this case now. So the following call generates the integer 4, 5, 6, or 7 randomly. 8 is not included. So if I specify np_random.randomInt, so I'm saying start from 4 and generate random numbers between 4, 5, 6, and 7. 8 excluded. So let's see that. So numpy has already been imported as np and a seed has been set. Can you roll some dice? So this time we're going to use np.randIt. Let me just copy this bunch of code. np dot rand int. I set the number between 4 and 8. 8 excluded. Use round it again. Repeat the outcome to see if the second row is different. Again, print out the results. Okay. So I'm going to use round it again. I'll just copy the same code. So I'm going to say print it out. I'm going to use print here. If I do prints, let me just copy this bunch of code here. Prints. I'm going to tell you to print this also. Now let's see it in action on Jupyter Notebook first. So it's rather than using just ordinary random to generate decimal numbers, we're using rand it now. Let me run the two code at once. It's generating almost the same results, but let me get rid of this. It's still generating 6 this time around. This generated 5. So depending on number, you can see that it can generate any random numbers for you. So that's what it does. If I run the same code in Jupyter in their interface, let's see. Oh, okay. You can see script 65. So generating different number. Check your core NP random. Did you correctly specify the first argument expected 1 but forgot 4? No. We said integer 1, 2, 3, 4. Okay, this is late. Okay, we have to start from okay. I'm following this. So I'm to start from 1 to 7. 7 rather. Okay, let's do 1 to 7. In this case, it's supposed to be from 1 to 7 in their instruction. I see. So it generates random 6. This one is 6, one is 3. So 7 excluded. Great. So the instruction was to generate random number between 1, 2, 3, 4, 5, 6 or 6. This simulate a dice. So this is like a dice, a normal dice in the real world scenario. Okay, we are getting there. It's making sense. So determine your next move. Now we've learned how to generate random numbers between. Let me go back to my Jupyter notebook and follow the instruction. So generate random number between 1 for dice 6. So I'm going to use 7 there. 7 excluded. So if I run this one more time 4, this time around 2. So that's how we generate random numbers there. Now let's determine your next move. So in the Empire State Building bets, your next move depends on the number you get after throwing the dice. We can perfectly code this with if, elif, else construct. So we learned all about if, elif in a couple of live stream back. So you really want to go back there and understand what if, elif, and else means in Python. You say the sample code assumes that you are currently at step 50. Can you fill in the missing piece to finish the scripts? NumPy is already imported as MP and the seed has been set to 1, 2, 3. So you don't have to worry about that anymore. So NumPy is imported, seed is set, starting step equals to 50. Roll the dice, finish the control construct. We want to finish this control construct here. So if dice is less than or equal to 2, step should be step minus 1. So you're going to minus step, this step a minus, so it's going to return 49. Elif, else print what? Okay, let's follow the instruction here to solve this challenge. Now let's see. It says roll the dice, use round it to create the variable dice. Okay, round it. Want to create the variable dice. We want to say dice equals to np dot random dot round int. So our dice is going to be okay. So our dice is going to be between 1 and 7. So 1 included, 7 excluded. So it's going to be between 1 and 6 this time around. So we've created the dice already. So randomly generates 0 or 1. So this is going to generate 1 or 6. 1, 2, 3, 4, 5, 6. So finish the if, elif, else construct by replacing. We want to replace this value here, and this value here, and this value here. Step equal to step plus np dot run. Okay, now let's complete this. It say if dice is less than or equal to 2, step equals to step 1, step minus 1. Elif is going to be, let's see what the elif is going to be. If dice is 1 or 2, you go one step down. Okay, 1 or 2. So this is less than 2. If it is equal to 2, you're going to go one step down. That is step 50 minus 1. So we go 49. If dice is 3, 4, or 5, you go one step up. Okay. Now I'm going to say elif dice is 3 is greater than. We could say it's greater than. Okay, we could say less than. We use less than also. Less than or equal to the highest number here, 3, 4, or 5. So less than 5. So you go one step. It's going to be step will now be equal to step plus 1. Else, this will not be else. So else is going to print step plus np random. It's going to use this step plus np random. So you're going to add step, this 50 plus any number generated from here. That is 50 above. So now say if dice is 3, 4, or 5, you go one step up. Else, you throw the dice again. The number on the dice is the number of steps you go up. So print out dice and step. Give the value of dice. Given the value of dice was step updated correctly. Okay, now let's print out a dice and step. So I'm going to say prints. Oh, let's print dice. Okay, we're going to print dice. So this is our dice here. We're going to print it. Dice. Then we're going to print step. That's our step. Or the step we're going to print should be. The step should be part of the this construct here. Now let's see it in action. Print out dice and step. Given the value of dice was step updated correctly. So let's print it first and see if you actually get it correctly. Oh, so it's only printed dice. This dice is 6. Okay, we need to print out step here. Okay, now let me write another bunch of code. Say print step. Now let's see it again in action. You can see dice is 5. Our dice is 5, which is the dice there. The random number generated there is 5. Then our step is 51. So if dice is less than or equal to 5, so it's going to be step plus 1. That is 51. So that means we nailed it correctly. Now let's see it in our Jupyter notebook here. Let's see in Jupyter notebook. So starting step is equal to 50. Dice is random number. Let's see it in action. You can see this is 2. So the dice that was generated here is less than or equal to 2. So that means step minus 1. So we're having 49 here. So we nailed this correctly. Oh, interesting. Pretty straightforward. Now let's submit the code. Code, you threw a 6. So the code for the else statement was executed. Okay, this was 6. Yes. The else statement code was executed. You threw again, and apparently you threw 3, causing you to take 3 steps. You are currently at step 53. Interesting. So we are getting there. We are getting there. It started to make sense. Random walk. Okay, let's solve one more challenge for this live stream. I see the content in the case study is quite huge. Oh, we didn't complete this part of the code. But let me just complete these parts. Okay, I think we've solved it there. Now let's go back to this random walk. Let's see how to let's solve this challenge also and solve the random walk. The next step, how long you go. visualize the work. Hmm. So we're just 30 minutes into the live stream. Okay, now let's solve this challenge also. Now let's do one more challenge, this random walk, and see it in action.
You are doing so well. Now, if you use a die to determine your next step, you can call this a random step. What if you use a die 100 times to determine your next step? You would have a succession of random steps. In other words, a random walk. This is a well-known concept in science. For example, the path traced by a molecule as it travels in a liquid or a gas can be modeled as a random walk. The financial status of a gambler is another example. To record every step in your random walk, you need to learn how to gradually build a list with a for loop. Have a look at this code. It keeps the outcomes for playing a game of heads or tails 10 times with the random number generator we coded up in the previous video. After importing NumPy and setting a seed for the random number generator, we initialize an empty list, outcomes. Next, we build a for loop that should run 10 times. We can do this with the range function that generates a list of numbers that you can use to iterate over. Inside this for loop, we generate a random integer coin that's either 0 or 1. 0 corresponds to heads, 1 to tail. We print the outcomes list we've built up in these 10 iterations. If we run this script, eventually a list with 10 strings will be printed out. This list is random, but it's not a random walk because the items in the list are not based on the previous ones. It's just a bunch of random steps. You could turn this example into a random walk by tracking the total number of tails while you're simulating the game. In this case, you start by creating a list, tails, that already contains the number 0 because at the start you haven't thrown any tails. Then you again start a for loop that runs 10 times using the range function. In there, you again generate a random number. Instead of the if-else structure, you can simplify things. If coin is 0, so heads, the number of tails you've thrown shouldn't change. If a 1 is generated, the number of tails should be incremented with 1. This means that you can simply add coin to the previous number of tails and add this count to the list with append. Finally, you again print the list tails. After running this script, a list with 11 elements will be printed out. The final element in this list tells you how often tails was thrown. If you compare the output of the first script to the output of the second script, you can see that the numbers in the tails list are incremented by 1 each time you threw tails. This is exactly how a bunch of random steps are converted into a random walk. Head over to the exercises to apply this new knowledge on your own case study.
Oh, now let's try this. Oh, notes. Okay, the next step. Ooh, the next step, how long can you walk? Visualize the work and distribution. Okay, I think we should stop here for today. So we're going to continue the case study on tomorrow, day 16. Probably just finish the case study on day 16. So on today's case study, we actually learned how to create random number generators and use loop in Python to throw a dice and generate random numbers, like normally when you throw a dice in the real world settings. That was that was quite interesting to see. Also, so that will be the end of the live stream for today. So tomorrow, day 17, we are probably going to complete the remaining part of the statistics, the challenge, or depending on how intense, how technical it is, we have to complete it on day 18. But let's give it a shot tomorrow on day 17 and see that in action. All right. All right, so thanks for staying to the end of the live stream. I hope you learned one or two things trying to solve this ACA statistics or case study in Python. As usual, do well to support the channel by giving the video a thumbs up, hit that subscribe button. Do well to catch up on previous live stream if you are finding it difficult to understand what is happening in this case study. I encourage you to go to day 1 and watch it all the way to day 15. I promise you, you are going to nail this case study It's just a bunch of codes, and a little bit of understanding is needed to solve it. All right, do have a wonderful day. Hit that subscribe button, share this video, and give this video a thumbs up, and finally, subscribe. I'll see you on day 17 or the next video on the channel. Bye bye for now. Peace.